Hello, welcome to Recitation Week 6. Today I will be reviewing some problems for your upcoming exams. Okay, so let's start with the first problem. We have f of t equal to e to the power of t, and g of t is e to the power minus 2t. Define for t greater than or equal to 0. And the question is we want to find the convolution of f of t with g of t. So what is the convolution of both functions? We can solve this with two different steps. The first step is, or first approach is we solve it by using the definition. So the convolution of f of t with g of t is integral from 0 to t f t minus tau multiplied by g of tau d tau. Okay, so this is the definition of convolution. So let's just substitute the function. We have e to the power t minus tau, and then g is e to the power minus 2 tau. This should be tau and d tau. Okay, from here we have 0 to t e power of t e to the power minus 3 tau d tau. So since the variable of the integration is tau, then we can put e to the power of t in the front, since it's not part of the integration. Then we just need to integrate e to the power minus 3 tau d tau. So this is e to the power of t, and you get minus 143 e to the power minus 3 tau from 0 to t. So it is e to the t minus 1 over 3, and then e to the power minus 3t. Just need to evaluate from 0 to t, this t, and then e to the power 0 is 1. Okay, so you have e to the power of t 1 minus e to the power minus 3t. You have 1 over 3 there, so 1 over 3 e to the power of t minus e to the power of minus 2t for t greater than or equal to 0. Okay, so this is the solution of the convolution. Second approach. We can use Laplace transform and Laplace inverse. So we know that the convolution, Laplace transform of convolution is just multiplication. So f of s multiplied by g of s, right? We know that f of s is, so since f is e to the power of t, then f of s is of course 1 over s minus 1, and g of t is e to the power minus 2t, so Laplace transform is 1 over s plus 2. Okay, and then we need to use partial fraction expansion. We should find the coefficient a and also b. Okay, what is a? A is s minus 1 to the function. Say this is h of s. Okay, s minus 1 h of s equal to 1. Okay, so it's 1 over 3, and then b is s plus 2 h of s when s is minus 2. Okay, if s is minus 2, then we get b to be equal to 1 over minus 3 or minus 1/3. Okay, so we get f of s multiplied by g of s is 1/3 s minus 1 minus 1/3 s plus 2. Okay, so we need to go back to the time domain by using inverse Laplace transform of f of s multiplied by g of s is 1/3 e power of t minus 1/3 power minus 2t, or 1/3 e power of t minus e power minus 2t for t greater than equal to 0. Okay, you see that we obtain exactly the same solution. So either way, you can use Laplace transform, or by using the definition of convolution. Okay, second problem. For second problem, we have initial value problem, x double prime minus 10 x prime t plus 9 x of t equal to 5t, with initial condition x0 is minus 1 and x0 prime is equal to 2. So we need to solve the differential equation given these initial conditions. So let's use Laplace transform. So Laplace it, we get what? We get, so Laplace of x prime t minus 10 x prime t plus 9 x of t is s square x of s minus sx0 minus x0 prime. Okay, and then minus 10 s f of s minus x0 plus 9x of s. Okay, by substituting the initial conditions, we get s square minus 10s plus 9 x of s plus s minus 12. Okay, and the Laplace of the input 5t is 5 over t sorry, s squared. Okay, so we have s squared minus 10s plus 9 x of s plus s minus 12 equals 5 over s squared. Okay, now you can move this to the other side, so we have s squared minus 10 s plus 9 x of s 5 over s squared, and then this one is minus s plus 12, right? But this is equal to minus s cubed plus 12 s squared plus 5 over s squared. So x of s is x of s is minus s cubed plus 12s squared plus 5. Here is s squared, then s squared minus 10s plus 9. But we can factorize it, this quadratic polynomial. So we get s cubed plus 12s squared plus 5 s squared, and then s 19 minus minus. Okay, so again we use partial fraction expansion. A over s plus b over s squared plus c over s minus 1 plus d over s minus 9. Okay, how to find b? B is s squared multiplied to x of s, and you substitute s with 0. Okay, we get 5 over 9, which is approximately around 0.55. Next, find c. C is s minus 1 multiplied by x of s when s is equal to 1. Again, we have minus 1 plus 12 plus 5 over that one is minus 8. So this one is 16 over minus 8, which is minus 2. Next is d. Similarly, d is s minus 9 multiplied by x of s when s is equal to 9. Okay, so this one you can compute as minus 9 cubed plus 12 times 9 squared plus 5 over 9 squared times 8, which is 31 over 81, which is approximately 0.38. And how to find a? So we can setting x of s, which is now we know that x of s is a over s plus 0.55 over s squared minus 2 over s minus 1 plus 0.38 over s minus 9, and then you substitute s with any number which is not a pole. Okay, so since the poles are 0, 1 and 9, then let's use 2. So you can substitute s equal to 2, and then of course x of s is minus s cubed plus 12s squared plus 5 s squared s minus 1 s minus 9, and then you substitute s equal to 2. So you can solve the equality and get a. If I'm not mistaken, a is around 0.61. Okay, from that we get x of s is 0.69 over s plus 0.55 s squared minus 2 over s minus 1 plus 0.38 over s minus 9. And from here we can just apply the inverse Laplace transform to find x of t, Laplace inverse of x of s, and we can just use the table. So the Laplace inverse of this is 0.61. The Laplace inverse of this is plus 0.55t. And this one is minus 2 e to the power t, and then plus 0.38 e to the power 90 for t greater than or equal to 0. Okay, so this is the final solution for problem number 2. Okay, next problem number 3. Find the pole of the following block diagram. You have this block diagram. This one is 1 over s, 2 plus minus. This one is 2s. We have a feedback 5. This one is minus, connected to here. Y of s. So yes, okay, so that's the block diagram, and the question is you have to find the poles of the transfer function of this closed loop system. Okay, so you just need to simplify this block diagram. So how to do it? The first simplification is to focus on this term right here. Okay, so we know that this block here is 1 over s plus 2. Okay, so it's 1 over s plus 2, or 2s plus 1 over s. Okay, so the first simplification is, this is u of s plus minus minus feedback 5. Now we have 2s plus 1 over s, and then this is feedback. This one is 2s y of s. Okay, now the next simplification is, I think we can move so this point behind 2s, the block 2s, to here, so before 2s to the point after 2s. Okay, so let's move this point. So if we move the connection from here to here, then since this point is not multiplied by 2s but here is multiplied by 2s, then we need to compensate by multiplying the signal with 1 over 2s. Okay, and we can combine these two signals so they become 5 over 2s, and of course this is this block, so in the green color this is nothing but negative feedback, so you can always simplify it. So 2s, this one is 2s over 1 plus 2s. Okay, but this block in green, which is 2s over 1 plus 2s, is multiplied by 2s plus 1 over s. So if you multiply these two blocks, 2s plus 1 over s multiplied by 2s over 1 plus 2s, then the resulting block is just again a block with 2. So u of s plus minus, this is 5 over 2s. You have a block with gain 2 after some simplification, and this is another big loop minus y of s. Okay, now we can simplify this block. So what is this block over here in blue color? So it's again a negative feedback. So you have 2 over 1 plus 2 times 5 over 2s multiply by 2s. You have 4s, 2s plus 10, which is equal to 2s over s plus 5. And this block here from another negative feedback. So you have 2s over s plus 5, and then 1 plus 2s over s plus 5. Okay, you can multiply with s plus 5 to get 2s over s plus 5 plus 2s, so 2s over 3s plus 5. Okay, so the final block diagram is the following: u of s, y of s, and the final block is 2s over 3s plus 5. So if you simplify it further, you can multiply it with 3 over 3. So 2 over 3 s plus 5 over 3. Okay, this one is 2 over 3 s plus 5 over 3. So the poles, or the pole, because there's only one pole, is minus 5 over 3. Okay, pretty simple. And that's the answer of problem number 3. The last problem, number 4. So problem number 4 is exam problem from the last semester. So the task is to find the transfer function of the following RLC circuit. So we have 4 components. The first component is inductor L1, and you have resistor right there in parallel with another inductor L2 series with capacitor C. And the transfer function is corresponding to the output voltage at the second inductor. So we want to find V0s over Vi of s. So this is the transfer function. How to solve this? The trick here is to treat these inductors and capacitor as impedance. So we know that the impedance of capacitor is 1 over SC in Laplace domain, and inductor is SL2 and SL1. Okay, so now we can directly use voltage division. Okay, let's say we define voltage across the resistors as VR. So from voltage division we know that V0 is SL2 over SL2 plus 1 over SC times VR, right? You can simplify it, multiply the numerator and denominator with SC, so S squared L2C over S squared L2C plus 1 VR. This is the first equation. Second equation, we need to establish the voltage relation between VR and the input voltage. Okay, so VR is the impedance of this, which is R parallel with SL2 plus 1 over SC, right? And the total impedance SL1 plus R parallel with SL2 plus 1 over SC VI. But V what is R parallel with SL2 plus 1 over SC? So this is equal to R times SL2 plus 1 over SC, and then R plus SL2 plus 1 over SC, right? So now the transfer function V0s over VIs is V0s over VRs times VRs over VIs, right? So this transfer function, the first one, you get it from the first equation. Okay, so S squared L2C over S squared L2C plus 1 multiplied by the second transfer function R parallel with SL2 plus 1 over SC, SL1 plus R parallel with SL2 plus 1 over SC. Okay, so you can substitute this, the R parallel with SL2 plus 1 over SC, in this equation. Okay, so after simplification you should get the simplified final answer, S squared R L2 over S cubed L1 L2 plus S squared R L1 plus L2 plus S L1 over C plus R over C. Okay, so this is the final simplified transfer function. Alright, so that's the answer of problem number 4, and with that, I'm ending this recitation lecture, and I apologize for any disturbances. If you have any question, please email me, and good luck with your first exam. I'll see you next week. Goodbye.